we were trying to find out total number of subsets. So if we want to do it manually, but not manually, if you want to do it by visualizing all the subsets, so you can visualize that there is a null set, and then there is an there are three sets of single elements, and you have around three sets of double element also. And then there will be a subset which will have all the elements of set. So the total number of subset will be 8. So it was very simple to visualize here. If the set for which we are counting, the subset has just 3 elements. But we still developed a way to count it by this way, that there would be 3 places, and any subset can be made by either uh, having A or by not having A. So for all the 3 elements, I have 2 options. So now it got converted into the similar problems where um, the place is being exhausted, but the element is not. So uh, at first place, I can keep 2, and whatever is being exhausted will count according to that only. So for the second place, I can put 2 elements, and for the third place, and at the third place, I can put 2 elements. So the total number of subset that we can have is um, 8. Okay. So for a smaller set, visualizing it was easy. But for a bigger set, let's say that there is a set A, B, C, D, E, F, and if you want to count the subset in this way, it will take a lot of time, because total number of sets would be 32. Okay. So now let's check another kind of example of counting. So the test question or test problem is, let there is a party where there is a party where there is a party where 10 people came, where 10 person came, and they everyone shook hand with each other. Everyone shook hand with each other. With each other. Now the question is, how many handshakes were, how many handshakes happened in the party? बताओ, how many handshakes happened in the party or in the party? कितना हुआ बताओ? How many handshakes must have happened in order to satisfy the condition that everybody has uh, actually shook their hand with everybody else? कितने होंगे? बताओ. So let's visualize this problem in this way. that these are 10 persons. One, two, three, four, five, six, 7, 8, 9, and 10. These
सर ये
are
तो कॉम्बिनेशन से बनेगा ना?
अभी क्या हम ट्राई कर रहे हैं तब से, वी आर नॉट यूजिंग परमुटेशन एंड कॉम्बिनेशन। इसके पहले वाले भी कई सारे जो क्वेश्चंस हैं वो कॉम्बिनेशन से बन सकते थे,
यस सर।
मैंने नहीं बनाया
हाँ सर।
बिकॉज आई एम नेग्लेक्टिंग परमुटेशन एंड कॉम्बिनेशन फॉर नाउ।
ओके सर।
ठीक है, पहले हम ये कैपेबिलिटी बिल्ड कर लें कि वी शुड नॉट relying upon just PNC, just permutation and combination. You should be relying upon your own logic that how it can be counted even if you don't have any formula. ठीक है,
ओके
so
सर।
ऊपर के कई एग्जांपल्स जो कल से हम ले रहे हैं वो अभी सब होंगे, and probably we will be visiting all those examples again in permutation combination discussion. ठीक है, so don't worry about that. I'm just let me और तुम्हारा तो दिमाग ऐसे बढ़ेगा ना कि हम इंडिपेंडेंट हो, हम किसी के भरोसे ना रहें वाइल प्रॉब्लम सॉल्विंग। नहीं,
यस सर।
हम्म, एक सेकेंड। तो ऐसे 4, 5, 6, 7, 8, 9, 10, तो 10 persons were there. Let's say these are the 10 persons. So we'll start counting from one. That one shook hand with all the 9 people attended the party except him, है ना, उसको लेकर तो 10 है। तो what we are getting here that A will shook hand, or of course everyone will shook hand with 9, कितना हो गया, सबको कितने बार करेंगे, 9 टाइम्स करेंगे। ठीक है, तो we will have two way to calculate this, है ना, मेथड 1, और दोनों ही मेथड ना प्रॉब्लम सॉल्विंग में काम आएगा कैट के उसमें। ऐसा नहीं है कि इसको हम लोग जस्ट क्या बोलते हैं फ्लेक्स करने के लिए बता रहे हैं कि आई एम दैट गुड। इट वी विल बी यूजिंग दिस मेथड टू सॉल्व अ डिफरेंट काइंड ऑफ क्वेश्चन देयर। तो अभी क्या है कि पहले वाले के लिए वी काउंटेड 9, so now let's take the second person. Nine. Let's take the second person. वो क्या होगा कि उसके लिए जब हम काउंट करेंगे, when we will count for second person, I will not count his handshake with 1 because that handshake has been counted. So then 2 will have 8 more handshake apart from 1, मतलब leaving 1, 2 will have 8 more handshakes. Then I'll go for person 3. Person 3 has already covered 1 and 2. So person 3 will left with 7 more people to shake his hand. And similarly, we will go on. I will find that total number of handshakes will be there. We can, matlab, total number of handshakes we can find by adding 1 to n. So basically, it will be 9 into 10 by 2. ये तो सब लोग जानते ही होंगे। जहां तक का सम करना होता है, सम ऑफ एन इंटीजर्स n इंटू एन प्लस 1/2। अब इसी को लोगों ने फॉर्मूला में ड्राफ्ट कर दिया। तो आपको बेसिकली क्या करना है कि अगर n पर्सन 10 की बजाय if there are n persons, so the formula would be n into n minus 1 by 2. I'll put here at the place of 10, I'll put n. At the place of 9, I'll put n minus 1 by 2. So many of the time, you might get this shortcut from the teachers, but the reason behind this shortcut is this. अभी पहले वाले मेथड में क्या था कि we realize that person 1 is shaking hand 9 times. Person 2 also 9 times. Person 3 also 9 times. So there are total count which we can do without neglecting the repetition. So there are 90 handshakes happened. But I know that in these 90, a, a pair of handshakes is counted twice. Every handshake is being counted twice. So like we are counting here 1 to 2, or again we are counting here the 2 to 1 uh, as a different handshake. So a pair of handshakes is same. So the total number of handshakes will be 90 by 2, which is 45. ये समझ में आया?
Yes, sir.
ठीक है. तो बेसिकली इसको भी अगर तुम रियलाइज करोगे तो इट हैपेंड इन द सेम वे दैट आई एम मल्टीप्लाइंग 9 into 10 divided by 2. So mathematically both of the methods are same, and even the method you can when you use combination here वो भी सेम होगा. मतलब फाइनल रिजल्ट उसका भी यही आएगा. मतलब आई एम जस्ट टेलिंग यू एन एग्जांपल because I have not introduced it. 10C2 would be the total number of handsets, और उसको भी आप एक्सपेंड करोगे तो 10 into 9 by 2 ही आएगा. So mathematically all are same, but logically all the three methods are different. ये समझ में आई तुम्हें बात अंकित?
Yes, sir.
Okay. So let me take one more example of counting, which is matlab, which is important for even which is important in numbers. So let's say that there is a number n which prime factorization is 2 to the power 3 into 3 to the power 2 into 5 to the power 2. And if somebody is asking that what will be the total number of factors of n, total number of factors of n, तो क्या होगा? How will you calculate? So you know that any number which can be made through 2, 3 or 5, and if that number's power is not exceeding the prime, the power of prime is not exceeding these powers, then that will be a factor of n. Like you can just take 2 to the power 1 and 3 to the power 2 and 5 to the power 1. This will also be a factor of this. But 2 to the power 4 into 3 to the power 1 into 5 to the power 1, this is not a factor of this number because the power is 2 is exceeded here from the original number n. So this is the basic criteria that how we can find a factor of a particular number. Now, if we want to count the total number of factors, then I'll say that I have to make a number which will be a factor of n, factor of n. So if I have to make a factor of n, I can take 2 in that factor with these 3 powers, and the 4 powers. We can take 0 power of 2 also, because there is no mandate, there is no restriction that the factor will have 2 or not. Similarly, we can use any of the 3 powers of 3, and we can also use any of the 3 powers of 5. And we are considering that every factor has 2, 3, 5. If 5 is not there, we can take the power 0 here. Okay. So, or 3 is not there, we will take the power of 0, or 2 is not there, we will take the power of 0 on 2. So even the factor 1 has all 3 primes, but with 0 powers. So the total number of factors we can make. So we have to put a power for 2, we have to put a power for 3, we have to put a power for 5. So we can put a power for 2 in 4 way. We can put a power for 3 in 3 way. We can put for power for 5 in 3 way. So total number of factors will be 36. ये समझ में आया सबको? So we use the same concept of counting here to calculate the number of factors. ठीक है, ये तो बात हुई हमारी सारी काउंटिंग की. Now we will go back to the example that I was giving you earlier, where the both variables are both variables are non-identical and exhausting. ऐसा कोई एग्जाम्पल बताओ फटाफट, ऐसा कौन सा हमने लिया था बताओ, where both were non-identical and both of them were exhausting. So one such examples was where you wanted to make a word of 3 letters from these 7 letters, let's say E, F, G. So you wanted to make a 3-letter word out of these 7 letters without repetition. With these 7 letters without repetition. तो इसमें क्या है कि repetition आपको नहीं करना है. You don't have to repeat the letters. So basically you have to arrange these letters in these 3 boxes, and every time when you put a particular letter in any box, the box will also exhaust and letter will also exhaust. So you did this calculation as you can put 7 letters here and then 6 here and any of the 5 years, not 7 letter, any of the 7 letter here And after putting one letter here, you will be left with 6 letters, and then you will be left with 5 letters. So the total number of words that you can make was 7 into 6 into 5. This we have studied. Now, what mathematicians did, they completed the series 7 into 6 into 5 into 4 into 3 into 2 into 1, and then divided it by the extra multiplication that we have used in numerator. So what you are getting here, 7 factorial by 4 factorial. Just see how it is happening. So we converted this into this, and then we converted this into 7 factorial divided by 7 minus 3 factorial, because we had 3-letter word to be made. Now, if you will generalize the similar situation that there are n letters, तो 7 को हमने n बोल दिया, and you want to make a r letter word, तो हमने 3 को r बोल दिया. So after this generalization, how many word we will find? We will find n factorial divided by n minus r factorial. और फिर इसी को we represented as NPR and we called it permutation. अब permutation word जो है, इसका मतलब होता है, the meaning of permutation word is arrangement. Okay, so basically just forget the situation which was to make a word here. It is same that we have 7 letters and you have to arrange 3 in a sequence. Out of those 7 letters, you have to pick 3 and you have to arrange that in sequence. So basically, NPR denotes what? Total number of arrangement of R element, of an element taking R at a time. Just remember the words. This is not the arrangement of 3 letters. This is an arrangement of 7 letters taking 3 at a time. So now you can define NPR as total number of arrangement of n letters, remember, or n elements, take R at a time. अच्छे से चल नहीं रहा आज. टेकिंग R at a time. ठीक है, यहां तक सबको एक बार घूरो तो अच्छे से. क्या हुआ, सबको समझ में आया? हाउ डिड वी
Yes,
गेट
sir.
दिस NPR? सबको समझ में आ गया?
Yes, sir.
क्या सिंपल कैलकुलेशन था? वी वेर डूइंग दिस, है ना. कभी हमें एनपीआर की जरूरत नहीं पड़ी थी. इससे पहले भी वी हैड मतलब डिड द सेम एग्जांपल, बट उसको हमने एनपीआर में नहीं बोला था. But now I have converted this into NPR. We have converted the simple 7 into 6 into 5 into 7 into 6 into 5 to 7 factorial by 4 factorial. So I have actually made it more complex. तुम सोचो पहली बार एक ऐसा फॉर्मूला आया है जो सिंप्लीफाइड चीज को और डिपिकल कर रहा है, टिपिकल बना रहा है. बट अगेन आगे चल के जो साइंटिफिक कैलकुलेशन है उसमें एनपीआर विल हेल्प यू मोर देन सिंपल 7 into 6 into 5. एनीवे अभी और बात करते हैं कि अब मान लो कि वी हैव द सेम प्रॉब्लम but we don't know any of the methods of calculating the number. Same problem हम रखते हैं यहाँ पे. I'll keep the same problem here that I have 7 letters, 7 letters A, B, C, D, E, F, G. I have 7 letters. I have to make a word of 3 letters without repetition. Without repetition. Without repetition बार बार बोलने की जरूरत इसलिए है because I want to make those letters to be exhausting. ठीक है, ये ध्यान रखना है तुम्हें कि ऐसे क्यों बोला. अब इसको हम दो तरीके से कर रहे थे. मतलब एक ही तरीके से कर रहे थे. इनफैक्ट हमने उसी को फॉर्मूला में बदल दिया कि we were having 3 places. First places was to be filled by 7 letters, then one of the 7 letters, then we were left with 6, and then we were left with 5. So total number of counting would be 7 into 6 into 5, which I converted into what? 7p3. तो आप ऐसे भी इसको सीधा सीधा निकाल सकते. ठीक है. अभी मान लो कि एक कोई बच्चा है जिसको ये चीज नहीं समझ में आया, उसको मैंने नहीं पढ़ाया, उसको सिंप्लीफाई नहीं करने दिया, हमने सिंप्लीफाई नहीं किया उसको. अब मैंने उसे बोला कि नाउ टेल मी हाउ मेनी वर्ड्स यू कैन क्रिएट. बच्चा भी जुझारू है, इज वेरी लाइक फाइटिंग स्पिरिट है उसमें. उसने बोला ठीक है सर, लेट मी डू इट इन अ वे कि अगर मैं कोई भी 3 लेटर लेता हूं, इफ आई टेक एनी 3 लेटर, it can be arranged in 6 ways. I mean 3 into 2 into 1 or 3 factorial ways. So अगर हमने कोई भी 3 अगर हमें मिलता है, now the real problem will be finding all such groups. So like if I have a group of ABC, 3 letter, I have a group of 3 letter ABC, I can make 3 factorial words from that. Then he started trying to count total number of group. So ABC word covered, ABD, then he took ABD, ABE, ABF. So it will take a lot of time to count actually all the groups. So if the number of groups, if the number of groups is X. So what answer he will make or he will give you? X into 3 factorial. And you know that it will be equal to what? 7p3 or 7 factorial divided by 7 minus 3 factorial. Now let's reverse the problem. Like I have given you, not reverse the problem. put the problem in a different way, that we know now. Okay, this is clear in our mind. Now, if somebody is asking that how many groups we can create, how many group of three we can create from these 7 letters, how many group of three we can create. तो आप बोलोगे कि सर this x is there, इसकी वैल्यू चाहिए मुझे, because the number of group we have taken as that as an x. So we'll say x is equal to 7p3 divided by 3 factorial, or you can put that in this formula that 7 factorial divided by 7 minus 3 factorial into 3 factorial. And then again, we can generalize this if the question is for n and r. Group of r from n article. Group of r from n article. So how will I generalize the n factorial divided by r factorial n minus r factorial. You can write any term. यहाँ पे मैंने 7 minus 3 लिखा था. So n factorial divided by r factorial into n minus r factorial. And then we defined this as NCR, which actually says, no, grouping is like combinating, making combinations. So combination of R element from n elements, or you can tell the same thing as making group from n elements, taking R at a time, of R size. So this is how we define the combination. So now you can just visualize that which will have a bigger value, permutation or combination. So let's take an example that 8 articles are there, or 8 different toys are there. You have to arrange 3 out of them, 3 out of 3 articles from them in a sequence. तो पहले बताओ which will be a bigger number, permutation or combination?
Permutation.
Permutation, because permutation is not only selecting the group, permutation is also arranging the group. So every selection will have certain number of permutation also. So basically, now we have 3 ways to do the same thing. Like we have to arrange the 3 article out of 8 articles. We could have done it as 8 into 7 into 6. Or we can calculate the same as 8p3. Or we can first make a group by 8c3. The total number of group would be 8c3. And then arrange later, that each group can be arranged in themselves in 3 factorial way. So can you find, or are you visualizing that all these 3 things will give you same value. All these three are the answer for this only. Are you able to visualize that? बोलो जल्दी.
Yes, sir.
Yes, sir.
अगर आप ये विजुलाइज कर लिए तो एक भी क्वेश्चन आपका मॉडर्न मैथ का नहीं फंसेगा. यू विल नेवर मिस एनी मॉडर्न मैथ क्वेश्चन, बिकॉज इसके बाद की सारी चीजें जो है वो बहुत टेम्पोररी, मतलब छोटे छोटे कॉम्प्लेक्सिटी पे बेस्ड है. ठीक है. तो आज मेरा पेन भी सही से नहीं चल रहा है, तो वी विल नॉट बी कंटिन्यूइंग द लेक्चर. इसको नेक्स्ट क्लास में हम कवर करेंगे.